Alrighty, kia ora. Rob Douglas, I'm reliability engineer at PowerNet. Yeah, and I was only meant to attend this as a delegate actually, but not to present. So yeah, I thought given the theme of the symposium and the recent events down south, I thought it'd be better that I should put something forward for it. Oh, okay. Oh, so quickly, PowerNet manages these six networks at the moment, and going through our basic structure, we are primarily ultimately owned by a power trust by the consumers of Southland, and in that structure there, through the power companies, the lines company, the distribution company, and PowerNet down here, OtargoNet and Lakeland Network. Okay, so quite a big area. So a large part of Otago, 68,000, it says customers on there, but more customers than that really, their connections. 12,500 kilometers of overhead lines, 165,000 poles. Note that number. That's a huge amount of poles. And if you divide the number of lines, number of customers, etc., you'll find it's quite a low density of customers. Okay, so let's go through the timeline of what actually happened last month. Okay, on the 22nd, we got an orange warning from the Met Service, came through, just come through email and on the news, etc. And we're pretty prepared for this. We've had a few of these, and we regularly get them for various weather events. And all our preparedness went into play, and we got ready. And the 130 kilometer an hour wind that was forecast is below historic design loads of our network, so we think, you know, it should be okay. Okay. Then the next day, on the Thursday, the weather front hits Southland, and suddenly the forecast suddenly becomes not very accurate, and they upgrade it to a red warning. And basically, it's now predicting wind loads over our historic design load of our network, 150. So about 133 kilometers an hour is our historic design load in terms of what we put on the line, what we've historically designed for. It's about 1930 or so. That's been the limits on the line. And we're getting predictions of 150 kilometers an hour. And the weather's already on us. And we get hit. This was just from notes to give an idea of where the wind was coming from. There was already red warnings here through Wellington and Canterbury. And basically, Clutha, Southland upgraded to a red warning. Okay, and basically got reports from a colleague who was in Bluff at the time when the front came through, and we got some videos come through just earlier, just before midday. I thought, lunch break, so I went out from my work out at Clutha. So I drove at the top of the hill, and could it put that full screen if you would? I just want to share this with you. I'll give you an idea of what the actual, can you go full screen? If you could download, yeah, full screen, yeah, okay. Presentation, if you will. Yeah. Oh, back again. Okay. So what happened? We had initially we hit our networks, and we had 35,000 customers initially off. We had 190 poles fail within not very long actually. It was a very, very quick hit. It's straight through, and thousands of wind-thrown trees. Thousands. don't know if anybody's driven down south lately, but if you go down towards Clutha, it's actually littered the ground. The place is littered with them. It was just really, really severely hit. There's our main line here. There's to Lawrence, and the other line, the other 33 line was hit as well. Conductors came down as well. This line was broken in 3-4 places, pretty severely, with poles down, cross arms. We haven't counted the amount of cross arms that were damaged, insulators that were failed, or conductors that had to be replaced, etc. But it was huge. And before you can even start, you've got to start taking down, cutting the trees down and stuff like that, and clearing roads and having access. Okay, so the Friday, we couldn't do much on the Thursday because the winds were too heavy until late into the evening. And then on the Friday, the extent of the damage was realised, and a state of emergency was declared, which lasted 2 weeks. Okay, so the restoration plans went into action, get the hospitals and stuff back on and all that line of stuff, gradually work through the lists, ring around, make sure everybody's okay and stuff, and getting things organised. Okay, so it's a bit confusing between the 35,000 down. We've got a restoration curve, but we've got smart meter data, we've got SCADA data, we've got a lot of manual systems and stuff. And it's pretty inaccurate in those first few days. So we've got a low duration curve, which but I haven't. Don't want to put it up at the moment because it's not very meaningful at the moment. So day 3, we still had 15,000 customers off. Day 7, 4,000. Yeah, and day 11, still 1,600 customers off. It was huge. Okay, so in the Otago, of the customers affected from the initial outage, after average days off 2.5, 90th percentile at 7, just over 7 days, and 50th percentile 1.3 days. So it's quite substantial outages. And for TPC, the power company, so the Southland excluding Invercargill, slightly less, 1.8, 3.3, 1.4. You can see the extent of the trees just everywhere like that. Huge plantations just wiped out, really, down south in the Catlins and things. Hundreds of thousands of dollars worth of trees lost. And the media questions was, what was the gust level? It wasn't forecast. Not quite sure what happened. We made contact with NIWA. We've been working together with NIWA. They're doing quite a bit of work with this. They've got a table of all these sample points around the region of what the gust level, what the wind speed and wind gust, 3-second gust was, but it's still quite unverified. But you're talking some figures there up into 1/200 at altitude, but there's a few in 190s and things. About 3 in 190s, some down quite relatively low actually, and then the 160s. So, but NIWA are working on that, and they're going to feed that into the structural loading standards 1170.2. And that'll come forward into the line design standards, and we'll get the whole return period for the wind and that. And what actually happened, 1 in 20, 1 in 50, 1 in 100, not sure. And then we've got to put into the terrain factors, which augment the wind as well, after that as well, into our line design standards. Then we've got to work out, I only know about like a couple of poles that actually failed on the Otago network due to wind. Everything else was trees. So what do we do? Hazard tree risk. We've got to reassess that. And further questions we'll ask later is, what was the value of lost load? We've got the GXP at say Clutha. We've got the dip there. It's quite an easy one to do at Clutha because there's not much generation going in, and the wind generation was offline. Southland's more difficult because there's lots of hydro and things interplays going on as well. But there's envelopes, well, 10 double-figure $1 million worth of lost load, okay? And then we've got to work out what the cost to the network was, and the damage, our response. And then we've got the further question is building into the resilience of the network, and from 165,000 poles, 190 failed, and the damage that was done. How can we make the network less fragile, or make it more anti-fragile and resilient? Okay, and we've got lots of data. That's down the Catlins, that one there. We've got lots of data which we haven't got the resources to use. And we've got to do a report on it it was an extreme event. SERDE of probably 1,500 minutes at least at the moment on each network or more. And compared to, that's an order of magnitude higher than our normal allowance. And it's unprecedented. Our SERDE on our network is looking at 1,800 at the moment on each of our networks. So the EIL, the electricity in Chicago, is pretty unaffected, really. Relatively small, a few hours, 10 hours possibly off. A few customers down a bluff. But to give it a bit of, compare it to Gabrielle Unison, 120,000 customers odd. So it's a wee bit more than us. They had about 1,800 SERDE minutes at distribution and 1,800 minutes at transmission. So about twice on Unison. So just for comparison. And that was a rain event, this is a wind event. So it's quite good, two useful natural experiments to look into, really. And social impact, who still had power on resources and things, and all the other costs. Yeah. Okay. Any questions, please?
Okay, one quick question for Rob.
How much work is done in terms of clearing trees before events happen, ones that could fall on lines, as opposed to cleaning up, and should more be done in terms of clearing?
Well, the state of emergency was called, and the council, I'm just speaking from the Clutha Council anyway, sort of hand in glove really in the road authorities. And if you can't get to the lines, you can't clear them. So primarily the roads need to be cleared before actually the crews could get in with the trucks and cranes and stuff to actually start moving stuff. So that was very important. And the electricity networks don't tend to do that. It's more left to other third-party contractors of the council, of the road and authority, who come in and actually do that work. That was a big, that was a big part of it.